service application from monolithic to microservices architecture. We use technology stack of Java 21, Spring Boot, RESTful web services with the microservices architecture. And coming to other areas, like we use AWS as a cloud, SonarQube for poor quality, JUnit with Marketer to write the unit test cases, Kafka as a messaging system, Docker as a container, Kubernetes as an orchestration tool. So these are the different tools and technologies we are using. Coming to my roles and responsibilities, I'm a Java full stack developer working on whatever the user stories which are sent to me, the respective stories development and the respective um, writing JUnit test cases, deployment validations, coordinating with the QA team, post-production verification. So all these things are all these things are I'm working.
Okay, can you come a little bit closer to the camera if you don't mind? Yes, that would help me a lot. Okay. Uh, how do you improve performance in Java backend application?
Multiple things we have to consider. The first thing is we have to check if we are relying on any queries. Are we using the indexing queries as part of the query cost optimization? So that's what we need to check. So whatever the queries we use in where class and under class must be indexed. Okay, and that is a basic level. If you go deep into the DB side, we can also use read cluster, write cluster, sharding, partitioning. These are all DB side improvisations we will do. If you are doing multiple backend API calls, instead of making them parallel, we could also make them as instead of making them synchronously, we can make them as parallel. So we can use completable feature from Java 1.8 to run the calls in the background, and we can use then apply, then compose and all of methods from completable feature to merge all these responses to create one outbound response. And we can avoid unwanted logging, okay, and unwanted synchronization. So yeah, and we should also write the logic, like we should not avoid data too much iteration. So all these things are like, okay, all these are the like different types of improvements, performance improvement scenarios in the Java backend side.
Okay, I got it. How can you explain me how Spring Boot auto configuration works?
So Spring Boot auto configuration, like when Spring detected some class on the class part, for example, dispatcher servlet, it will automatically execute dispatcher servlet auto configure to register the dispatcher servlet as a front controller. Similarly, there are so many auto configuration classes are available. For example, data source auto configurer, Redis auto configurer, right? RabbitMQ auto configurer. So this auto configuration feature in Spring Boot without writing any code to reduce the development time. So what we redundantly configure from application to application would be automatically done. It's because of enable auto configuration annotation. It is a part of Spring Boot application annotation. So we no need to do anything that is inbuilt available. If you wanted to stop, okay, for example, I don't want data source auto configured, we can use exclude attribute in the Spring Boot level or enable auto configuration level. We can use exclude attribute to exclude specific auto configuration.
Okay, but how will you override default behavior?
Through the exclude attribute. So enable auto configuration, exclude data source config.class to exclude a specific configuration. If you wanted to completely disable, we can write some property in application.properties file. But that is one of the key benefit of using Spring Boot, right? So we can exclude few auto configurations we want.
Okay. How do you manage transaction boundaries in Spring Boot microservices?
So Spring Boot transaction boundaries in the sense, actually, at the rate transactional annotation in Spring Boot will work only in the Spring Boot application level. So there are so many Spring Boot applications, right? Whenever we are talking about microservices, like a shopping cart, e-commerce, user profile, payment, shipment, acknowledgement, notification service. Like this, there are so many things. So when we use at the rate transactional to define the boundaries within one service. So when you put at the rate transactional, so the transaction will always get associated with only a particular microservice. Otherwise, we can also use two-phase commit, okay, to our saga design pattern, which is orchestrative saga or choreographic saga. So to achieve the transaction management across multiple microservices, if the transaction is distributed across multiple microservices, we can use saga design pattern. If it is a microservice level, it is a transactional annotation.
Okay. Okay. Can you explain how Spring Boot simplifies microservice development compared to traditional Spring?
Um, Actually, Spring Boot is built on top of Spring. So whatever the features are available in Spring, like bean creations, auto wiring, dependency injection, all those things are inbuilt available in Spring Boot. Apart from these features, Spring Boot offers extra features like auto configuration, reading the application.properties file YAML file. Specific to microservices, if we are talking, we can containerize Spring Boot application using embedded Tomcat server. So we no need to deploy our application on an external server. We can package our application as a Docker container, which internally have embedded Tomcat server. So it is best suitable to deploy our applications into cloud microservices design pattern. So when it is a Docker container, adding one container, removing a container, so all these things are pretty much easy through Docker. So Spring Boot is inbuilt, supported, running on embedded Tomcat server. No explicit server is required. Automatically read the configuration. Configuration also internally supported. There is one project called Spring Cloud to build microservices, whatever the challenges we have, like API gateway, service discovery, circuit breaker, distributed logging, distributed tracing, all these are solutions are available from Spring Cloud. We can integrate the Spring Cloud projects with Spring Boot very much easily. There is a starters concept. We no need to maintain each and every dependency manually. Just add the respective starter. It will automatically add the required internal dependencies and the manage required versions also, interrelated versions also will get automatically managed because of the starter. So there are so many benefits. So whatever I told, like very high level, like running an embedded Tomcat, auto configuration, starters dependencies, and actuators, production ready support actuators like this, inbuilt Spring Cloud integration for microservices. All this will make Spring Boot is the best suitable for microservices today.
Okay, got your point. Uh, if you have a monolithic application which needs to be broken into microservices, can you let me know your approach, service boundaries, data migration, and inter-service communication?
Yeah, breaking a monolithic to microservices. My knowledge is like relying on the domain-driven approach, classifying the APIs based on their type, keeping all user-related operations into one microservice, keeping all cart-related operations into one. So we need to understand the monolithic application, analyze what APIs are available, what the business domains are available. Then we can use domain-driven design to find or create the boundaries for microservices. So we have to categorize the APIs, put it into different microservices. And we should also consider using design principles like solid design principles, and what challenges we are going to face when we migrate it into microservices. For intercommunication between the microservices, I can see there are two ways, like HTTP, synchronous communication. We can use REST template, web client, or Google gRPC, right, OpenFN to make a HTTP call from one service to another service. That is a synchronous communication. And another way of communication is asynchronous communication or event-driven communication. We can use Kafka, right? We can use Kafka to what is that? We can use Kafka to send or like work in a published subscribers. So we can publish the message, subscriber will subscribe it and process it. So the customer no need to wait until that request to get completed. So we can use an asynchronous process.
Okay. If you notice a backend service is slowing down due to DB queries, how would you diagnose and fix performance bottlenecks?
With respect to DB queries, right?
Mm.
Yeah, that is what we discussed initially, right? Like um, uh, like we need to check the query cost, where we are using indexed queries or not. So we can check the queries must be indexed. If you keep on hitting same queries again and again and again and again, it's better to use some cache technique like Redis cache, something like that. And we can also use different data centers. So the people who are in India, they can read the data from availability zone of India. The people who are from US, they can read their requests can be navigated to US data center. And we can also use partitioning, sharding to improve the DB performance.
Okay. How does BigQuery differ from traditional RDBMS system?
No SQL versus SQL.
Yes.
You were asking about NoSQL versus SQL.
Yes.
Actually, all the RDBMS databases will work on a tables, columns, rows architecture. Every database, whether it's a MySQL, Postgre, Oracle, IBM DB2, whatever it is, everything will work on a column, rows, tables, and everything will support ACID property, atomicity, consistency, isolation, durability. Like, and all these databases will support SQL as a query language. But coming to NoSQL databases, every database will work in a different architecture. For example, if you take Google BigQuery, so that is a document storage, right? It is not column, table, those things. And SQL databases, NoSQL databases, like Cassandra column based, means document based, BigQuery means document based. So we need to find which database is suitable for us. So, and these NoSQL databases will work on CAP to consistency, availability, partitioner. So most of the databases high available. If I want more consistent, tunable consistency, high availability, tunable consistency, high consistency, low availability. Like this, we might have the challenges. So most of the NoSQL databases are better for storing and reading the data. They are not best suitable for transactional related. So sensitive data, transactional data, we can use RDBMS. Other scenarios like user profile, simple data, not transactional related, we can use NoSQL databases. So there are so many NoSQL databases in the market, like Cassandra, MongoDB, BigQuery, Amazon, AWS DynamoDB.
Okay. If you need to integrate backend services with BigQuery for analytics, okay, how would you design ETL pipelines
BigQuery,
for analytics?
BigQuery, if you backend application, right? Backend
Yes,
application.
yes. If you need to integrate backend services with BigQuery for analytics,
Okay.
how would you design ETL pipelines?
Okay. So only specific to talking about BigQuery, the Google BigQuery database. So ETL pipeline, first of all, the backend captures events like user actions, orders, payment. These events are sent parallelly, asynchronously to queue, publish and subscribe. So it does not affect on the performance, right? So the data processing layer, maybe we can use data flow, Spark, which will cleans, validates, and accomplish the data. This is the transform step. So after that, the processed data is loaded into BigQuery tables, usually in append mode and partitioned by the date or to read the data fastly. So if we want huge data processing, we can use batch also, batch data. We may also load first into data into the cloud storage, from the cloud storage to BigQuery. Something like that, we can design a system.
Can you explain CI/CD pipelines in Azure DevOps for microservices deployment?
Specific to Azure.
Yes.
Yeah. So in Azure, like we can use Azure pipelines like Terraform for microservices, right? Infra pipeline, app pipeline. So when developer commits the code, Azure DevOps pipeline triggers get triggered automatically because we will put a hook there. It runs the build unit test cases and creates a Docker image, then pushes to Azure Container Registry. Once the Docker image is built, there is an Azure inbuilt container registry where we can. So then by using Terraform, we can deploy the code into AKS, Azure Kubernetes Services. So we can use app service, load balancer, key vault concepts to integrate the data. So we can write the files, Terraform files to do this. So then pipeline deploys the new image, the new Docker image into the AKS using Helm or Kubernetes. So with the rolling blue-green deployment architecture concepts, we can follow.
Okay. If a developer accidentally pushes faulty code to main, okay, how would you handle rollback and prevent future issues?
Um, but uh, no, we will have a PR concept, right? Pull request and merge. Then we can deploy the changes to dev, then QA, then production, right? If you're saying if the changes goes to the production, then we can use blue-green deployment architecture to deploy the changes back to the blue environment, which was earlier stable one. So this is like a critical issue, right? If the developer accidentally push bug code to the production, so we would immediately open a save one ticket to the production team to quick rollback to the blue environment to make the environment stable.
Okay. Your team is missing sprint commitments repeatedly. As a senior developer, how would you address this?
Uh, First of all, if keep on spillover happening in sprint, okay, then we should plan the sprint properly. Okay, and we should make sure in the retrospect we should come up with the plans actually, so we can break the stories into smaller achievable tasks. we can improve the refinement, right? And estimation. So it would be mostly problem with estimations. If we give the wrong estimations as part of development, if the estimations are wrong, the effort will increase. Obviously, that story might spill over to the next sprint. So we need to find the bottlenecks like environmental issues, approvals, what is the complexity with the user stories, where the team is getting stuck, how we can come over those issues, some environmental issues, how we can avoid them. So we can also make sure we connect the team very frequently, like maybe like morning with the daily stand up, evening with the onshore sync up call to understand the status of the ticket, where exactly, I mean, how much the team has been progressing. So we can track the progress daily and raise the concerns immediately instead of waiting till the end of the sprint.
Okay. If your client complains about unauthorized access items, how would you investigate and mitigate?
The first thing we can put the API gateway level whitelisting the URLs from where we are getting this unauthorized access attempts. I'll treat it like it's going to be a security incident, right? So we can check the security logs, application logs, firewall, IAM rules in AWS. So we can block suspicious IPs and we can temporarily lock affected accounts. So we can make the customer to reset their passwords or token generation immediately. So we can also rate limit or we can integrate CAPTCHA, Google reCAPTCHA something to make sure it should not be the robo submission, right? It should be a manual submission. So something like that, we should properly provide like mitigate that issue. Yeah.
Okay. Uh, can you explain the difference between OAuth2 and OpenID Connect?
WAF 2 versus OpenID Connect.
Yeah.
So WAF 2 is like a different thing, right? Like what to say, it's like a complete server, right? It's mainly for authorization. So it allows an application to access user data without sharing the password by using access tokens, something like that. OpenID Connect, it's it is built on top of Auth2 and it is used for authentication. It adds an ID token to user or user info endpoint so the app can know who the customer who is accessing them. So what app can read your Google Drive files, something like that. OpenID Connect is it's for authentication purpose.
Okay. If you need to secure a REST API with Azure AD, can you let me know the implementation process?
Securing a REST API with Azure Active Directory.
Yes.
Mm, yeah, so for that, what we should do, we should like first we register an API with Azure Active Directory, and we can specify the roles of different users or groups, and we can register the client application and grant the permission to call that API. If the client authenticates with Azure Active Directory, we may get like a JWT access token using Auth2. Then the client sends the token in authorization as a parent token. We can write a filter which will extract the token. We can write a filter which will extract the token from the header, and we will connect with Azure Active Directory to to uh, check whether that user is authenticated user or not.
Okay. One microservices is slow and impacting others. How would you isolate and resolve the issue?
If it is slow, means we need to find it, right? Like if a microservice is slow and impacting the other microservices performance, so we need to identify. Better to go to the tools like New Relic or Prometheus to find in which scenarios, which metric scenarios we will be able to like when the high throughput is coming, what issues are coming. So something like that we have to identify. So is it because of the deadlocks? Is it because of the high throughput? So if the latency because of less number of services, so did we enable the horizontal scaling? So we should come up with those kind of scenarios to avoid the performance issues of the microservices.
Okay. I'm done with the interview. Any questions from your end?